All right, we're going to be looking at graphing hyperbolas and equations of hyperbolas. So this is the standard form of a hyperbola. The first thing to note is whether it's vertical or horizontal. If the x squared is positive, it's going to be a horizontal hyperbola. And in this case, the x squared is positive, so it's a horizontal hyperbola. The next thing we're going to look at is where's the center. Here, x and y aren't translated at all. So the center is at 0, 0. And then just like with an ellipse, we're going to call it the x radius. Ugh. It's not great vocabulary, but it's okay. The x radius is going to be a here. And remember, this is the x radius squared. So the formula is x squared over a squared minus y squared over b squared equals 1. And so this is a being squared, and so the x radius is 5. So we're going to go 5 to the right and 5 to the left. These are our vertices, because this is a horizontal hyperbola. And then the y radius is going to be the ends of the conjugate axis. So the y radius is 3. So 3 up, 3 down. And this is where we form our x box. So this is the transverse axis, the conjugate axis, and where those endpoints meet up, we're going to make another set of points, and our x box goes through those points and the center. This is where the asymptotes of the hyperbola are going to be. So there are the asymptotes of the hyperbola. And again, because this is a horizontal hyperbola, these are the vertices, and we're going to follow the asymptotes like this. Okay. I'd like to show you a few small changes. If this had been a plus instead of a minus, it would be an ellipse. And the ellipse, we would have graphed in these exact same points. The x radius, y radius would have been the same, and it would have looked like this. If we had switched this and made this negative and this positive, now one of them is negative, and it would be a hyperbola. Except now, the y would be positive, and it would be a vertical hyperbola. That would look like this. Okay. So now this graph is kind of junky. We still need to do a little bit more with it. The foci. Well, the focus distance here is actually going to be inside of the hyperbola. So it's a little bit further than any of the vertices. So instead of, remember for an ellipse, we did the focus distance is the square root. We would do square root of 25 minus 9. But now, the focus distance is going to be the square root of 25 plus 9. So the square root of 34, which is just a little bit less than 6. That is the distance from the center along the transverse axis. So it's going to be right here, just inside of the hyperbola on each side. This is where the square root of 34 is. So square root of 34 away, square root of 34 away. The foci are negative square root of 34, 0, and positive square root of 34, comma 0. Okay, I think that's good for now. We could do the equations of the asymptotes. The rise is 3, the run is 5, and so the equation is y equals 3/5 x, and y equals negative 3/5 x. Those are the equations of these linear functions here. All right, let's do quickly one more example of graphing it. This is now a vertical hyperbola because the y is positive and the x is negative. This one also is different because the center is transformed. It got shifted 4 to the right and 2 down, or 4 up. 4 up and 2 to the left. So the center is going to be at negative 2, 4. The y radius is 3. The x radius, this is being divided by 1. It just wasn't written. So the x radius is 1. And this is where I'm going to form my x box. And again, because this is a vertical hyperbola, the vertices are here and here. Bam. Great. We could also find the foci. It would be square root of 10 up from the center. Square root of 10 is just a little bit bigger than 3. And so these points would be, this is the foci, would be negative 2 comma, what is this point? This is 4 plus the square root of 10. And we also have -2 comma 4 minus square root of 10 because we went down by the square root of 10 from here. So that's what's up with that. I'd like to do one more example before I have to go. There's somebody here who's going to need to take a quiz in a second, so I got to hurry this. The last thing is, what if we had to graph an equation like this? 9x squared plus 18x minus 4y squared plus 16y equals 43. Okay, well, this is one of those ones where we're going to complete the square. And just like before, we're going to factor out the common factor here, or the coefficient on the x squared. 9x squared plus 2x, we're going to leave a space here. We're also going to put minus, and we're going to factor out this 4, it's going to be y squared minus 4y. Then we're going to leave ourselves some space here. This is going to be a square binomial, and so the square we need is x plus 1, because these have to multiply and double to make this. Now if that's x plus 1 squared, then this is really a 1 that we needed here. Again, if we added 9 out of nowhere, this is not really a 1 because it's getting multiplied by 9. If we added 9, we also need to subtract 9 to cancel it out. Or we could think about it as adding 9 on the other side, because we're going to move this minus 9 to the other side by putting plus 9 plus 9. It's a lot easier to think about it as just, hey, we added 9 on the left side, we'll add 9 on the right side. The y's, this is going to be minus 4 times y minus 2 squared. And this is also a plus 4. Now this was minus 16. So we're really subtracting 16 here. So since we subtracted 16, we're going to subtract 16 on the other side. And so our equation ends up being 52 minus 16 is 36. We can divide both sides by 36 to get it into the standard form. And we reduce. Here we can divide both of these by 9. So x plus 1 squared divided by 4 minus y minus 2 squared divided by 9. We divided both of these by 4 equals 1. And this is the standard form for a hyperbola. We can see the center is at -1, 2. It's a horizontal hyperbola because the x is positive. The x radius is going to be 2 and the y radius is going to be 3. And we can even already see that the focus length is going to be the square root of 13 by adding these two together and taking the square root. And we're ready to graph it at this point. Hopefully this is helpful. Good luck on your day today while I'm not